All right, good morning, ladies and gentlemen.
Good morning.
We are on indirect measurement, January 9th, 2014. We're dealing with problem number 2 after we defined indirect measurement. And we know that Jeffrey wants to put a tree in his living room. We have a lot of information already done. We know that the building that he is standing next to is 30 feet tall and it casts a shadow that's 75 feet long. He also has determined that the shadow of a nearby tree is 35 feet long. And he now wants to know the height of that tree. So 15-foot height, or 15 feet is the height of his living room ceiling. Can he fit that in there? Mr. Pottinger, myself, I was confused on how to do this problem. So what I did is I drew a building. I just drew my information and I wrote down my measurements. I know the building was 30 feet tall and I knew that it cast a shadow 75 feet long. And then I went to the tree and I measured it. At the exact same time I measured the building height. Because of the sun, we have to make sure it's the same time of the day. The shadow is 35 feet of the tree. P.S. Here's the sun. And the height of the tree is X. So what are you going to do using indirect measurement to solve to see if this tree will fit into the living room? Jeffrey, can you tell us how you set this up?
Get a proportion.
You set up a proportion using a couple of ratios. So tell me how you did this. What did you set up for your ratios?
I did the height of the building.
So you did the height of the building, which is what?
30 feet.
The building is 30 feet tall.
And then over 75 feet the shadow.
The shadow of the building is 75 feet. Awesome.
And then equals X feet over 30.
And he said it equals the height of the tree, which we don't know, over the shadow length of the tree, which is what? 35 feet. So Jeffrey, how did you solve this then?
I did cross multiplication.
Cross multiplication. So tell me what you got when you did your cross multiplication.
30 times 35 is 1,050.
1,000. What? Ooh, where did that 3 come from? 30 times 35 is 1,050. And
75x.
equals equal to 75x. Keep going.
I divided by 7. I had 75x equals
So you divided by 75 and you got what?
x equals 14.
X equals 14 feet. You guys cool with that?
Yeah.
Can Jeffrey cut this tree down and bring it to his living room?
Yeah.
Do we care how he's getting it there? No, he can figure that out himself. Okay. Freeze for a moment. This would be an example of indirect measurement. We solved a problem. Jeffrey was unable to climb the tree. We took the information that we had. He did what he could do. Figured out how tall that tree was and if it could fit into his living room. Questions on how we did that, Zachariah? For sure you'd get a different answer if it came at a different time. But if you did the tree and the shadow measurements at the same time, it's still always going to work out to be 14 feet. The tree's never going to change its height. Well, it is as it grows. But in that particular time frame, you just have to make sure you do it at the same exact time. Because the proportions, or the ratios are going to change proportionately. Right? The shadow is going to get shorter or longer in the same way that the shadow of the tree. The shadow of the building is going to get shorter or longer in the same way the shadow of the tree is going to get shorter or longer, right? 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 Right. Okay, just for fun, could I set my proportion up differently? And could I go, instead of saying, I could say the building is 30 feet tall and the tree is X feet tall, and set that equal to a 75-foot shadow of the building and a 35-foot shadow of the tree? Could I set my proportion up like that?
Yeah.
Are you still going to get 14 feet?
Yeah.
Sure are. Okay, question?
I actually read a book and it taught you how to measure a tree without that. It's like with a pencil, you hold it up and measure the tree, step back until the pencil is the same height as the tree. Then you tilt it over and have your friend walk until the end of the tip of the pencil. And then you do like Pythagorean.
People watching this video right now, that's Charlotte talking about a really weird way to measure a tree. Thanks, Charlotte, though. That's really good. I'm glad you read a book, too.